In this video we're going to take a look at some of the homework problems from section 5.3. The first problem I would like to take a look at provides us a graph for a function g of x, and g of x is defined to be the integral from 0 to x of f of t dt. And again, the graph here is provided. And we're then asked first in part A to evaluate g of x for the following values: g of 0, g of 3, and so on. So really what the question is asking is, can you find the accumulated value at each one of those points? So you can see that at g of 0, nothing has accumulated. So really g of 0 means, really means the integral going from 0 to 0 for this function f of t dt. So there's no accumulation. So the value for g of 0 is equal to 0, right? At g of 3, let's go ahead and fill that in. So g of 3 would be the integral from 0 to 3 of f of t dt. So in other words, from here to here, what is the accumulated value? And so we really can just go ahead and kind of just calculate the area under the graph. So there you go. We can see that, this is a 3 by 3 square. We're calculating half of that, so that will be 9 halves. So 9 halves, I'll have to write very tiny, or if you'd rather write 4.5, that is okay. All right. So at g of 6, we can see, if I'm going to go ahead and shade all the area between the graph and the x-axis between 0 and 6, you see that these two regions really will actually cancel each other out, right? So we're back to having a function value of 0. Again, g is the accumulated value. All right. Next, g of 9. So at g of 9, we're now adding a little bit of negative area. And so we're adding, again, one of these little negative triangles. So now we will be at negative 9 over 2, or if you will, negative 4.5. Right? At g of 12, we're again adding a 1/2 of these little squares. And again, you can see that these two regions will cancel each other out. And again, my accumulated value is 0. All right. At g of 15, we're adding one little 3 by 3 square, and then another half of those. So really what we have here is a 3 by 3 square. So this is a area of 9, and then this little half a guy, that's an area of 9 halves, right? So 9 plus 9 halves is going to give me 13.5. All right, and then finally g of 18, again, we're going to add in 2 more full squares, and then another half a square. So again, there's another 9 units, another 9 units, and another 9 units. So really 4 times 9, this gives an accumulated area of 36. In part B, we are asked to estimate g of 21 using the midpoint to get the most precise estimate. So for this midpoint, if I am asked to use the midpoints, again, I'm going to kind of clear this off for you, and we're going to go ahead and calculate these midpoints. So the midpoint on each one, if I subdivide this into 1, 2, 3, 4, 5, 6, 7 equal subintervals. Each subinterval, for instance, here's my first subinterval. Each subinterval has a width of 3, so delta x will be 3. And then the midpoint here, so really we're finding the y value right here. Right? So this midpoint will be 3 times, all right? And I'm just going to tally up my midpoints. So this will be, I'm guessing this right here is about 1.5, right? So this will be 1.5 minus, so again, right here, this midpoint right here, again, will be at negative 1.5, so minus 1.5. Right, again, the next midpoint is at negative 1.5. The next midpoint, again, is at plus 1.5. all right, plus, let's see, the next midpoint, that would be, again, if you kind of go up here. So this midpoint right here is at about 4.5, so plus 4.5. The next midpoint right here, let's see, this y value will get me to, I want to say this number right here is probably about 7.5. And then for the final midpoint here, let's see if we go up on this last interval. Again, it kind of looks like, again, about 7. So I'm going to say plus 7.5. If you want to make your calculation a little bit easier, you can see that those two cancel out. These two guys cancel out. And so we are left with 4.5 plus 7.5 plus 7.5, quantity times 3. That gives me a value of, I get 58.5 when I calculate. So that would be 58.5. All right, the problem goes on to ask, where does G have a maximum value? And so again, we kind of want to just kind of consider over here, this interval right here, right? So the function goes from 0 to 4.5, back to 0, back to, or down to negative 4.5, then back to 0, then to 13.5, then to 36. So it looks like the minimum value occurs when G, when we plug 9 into this function G, and that kind of gets us here to negative 4.5. So I will say we attain a minimum value at x equal to 9. And then the maximum value seems to be right here, where x is equal to 18. And then the final question here is to see if we can draw a graph. So again, I'm going to kind of just jot this down. And again, so at these intervals, so at 0, the function value is 0. At 3, the function value is 4.5. So we seem to kind of go up just a little bit. At 6, my function value is back to 0. At 9, we're at negative 4.5. At 12, we're back to 0. At 15, we're up here at 13.5. And then at 18, we're up here at 13.6. So although I don't really know the curvature of the function, it kind of seems to have maybe this shape, something like this. And so if we look at the possible answer choices, I'm going to say that one that matches is this guy right here. This is the answer choice that matches. All right. All right. Let's take a look at another problem. The next problem says sketch the area represented by g of x. And again, here g of x is the integral from 0 to x of 5 plus sine of t dt. Well, first of all, if you know what the graph of sine looks like, add 5 to that, I can sort of immediately eliminate these two. But we are looking at the accumulation from 0 to x, and it does seem like this is going to be my answer choice. We'll go ahead and maybe block this. Right? So that is both the graph of 5 plus sine of t, and it shows the accumulated value from 0 to x. The problem then says, what is g prime of t? So here we're going to use the first fundamental theorem of calculus. We're taking the derivative of the integral. So we kind of refer to this as the do-nothing theorem, especially in this case where we integrate from a constant to a variable. Really all we're going to do is just replace the variables. So this will become 5 plus sine of x. And there's nothing more to it.